Hello everyone. Before we start the class, I will want you to get your pen, your book, and let's start. Now the topic we are going to look at is heat energy, and this are the table of contents for heat energy. We look at the introduction, effects of heat transfer, heat capacity, and latent heat. Then we'll wrap it up with humidity. Let's start. Now when we feel heat on the fan or AC, if you don't have either of the two, we look out for the natural air. Interestingly, we use heat to iron our clothes, cook our food, and even to keep our body warm. Now, the question is then, why do we feel uncomfortable with heat? I leave you guys to answer that. Now, what is heat energy? Heat energy is an internal energy possessed by a body due to temperature difference or temperature gradients, which means if there is no heat changes, if there is no temperature changes, heat will not be generated. This energy is also known as thermal energy. Now let me quickly explain this. If you are talking about heat, now heat is as a result of what? Temperature gradients. Now if temperature is also constant, there is another type of heat that can be absorbed or given off, which is known as what? Latent heat. It does not mean that temperature must always change to generate heat or for heat to take place. So, and then heat is also what? Internal energy. It's also a residual form of energy when we have energy transformation. Let's take for instance, we have from mechanical energy, let's say mechanical energy to electrical energy and the likes. Most time when energy transformation is taking place, heat will also be generated, and it's as a result of what? Now, heat will be a residual energy that will be generated when energy transformation is taking place. Now, we can take for instance, if we switch on our our bulb, our electric bulb, you discover that we are converting electrical energy to light, and as a result of this, we have heat being generated by our bulb. So it can also be said a residual form of energy that is generated when energy transformation is taking place. Now, heat energy is also the residual energy that is generated when energy transformation is taking place. Example of heat are heat from the sun, cold from the AC, heat from the combustion of fuel, heat from the earth crust, which is also known as what? Geothermal, heat from some chemical reaction, endothermic reaction. Now, if you want to talk about heat, we need to talk about a guy, and the name of that guy is temperature. Now, temperature is the degree of hotness or coldness. Temperature is the degree of hotness or coldness of a body. It is also the average kinetic energy of a body. Now, let's quickly talk about thermal conductivity. This is the ability of a material to conduct or absorb heat. Now, let's quickly talk about this temperature again. Now, especially the second definition, which says that temperature is the average kinetic energy of a body. Now, if you want to talk about average kinetic energy, you're talking about all the kinetic energy possessed by individual particles of the body. Now, you now find the average to get the temperature of a body. Question can come out on this, the average kinetic energy of a body. Temperature. Now we have thermal conductivity. Thermal conductivity is the ability of any material to conduct or absorb heat energy. Now that property of a material to absorb heat, which means to take heat energy, is known as thermal conductivity. Now let's look at temperature measurements. Now to measure temperature, we need a substance that changes its physical properties as a result of change in temperature. Any substance that changes its physical properties as a result of change in temperature are known as thermometric substance. Example are mercury, alcohol, thermistor, and the likes. Let me quickly explain. To measure temperature, it's not only temperature. To measure anything, you are using a sensor. We call it a sensor. If you are using a sensor must be able to change its physical properties as you have change in whatever you are measuring. Changing. So that is called what? Thermometric. For instance, if you want to measure temperature, you need a substance, you need a material that changes its physical or properties. The properties that you can see as temperature changes. Now, on this table, I have a lot of thermometric substance here. Let's look at different type of thermometer or temperature sensors and their thermometric substance, their thermometric properties. Now let's talk about liquid in glass thermometer. Now liquid in glass thermometer is using mercury or alcohol as a thermometric substance. Now the properties that we are using here to measure temperature is expansivity, change in volume. As we are using this thermometer, this thermometric substance will be increasing in volume or decreasing in volume. So, and we are using that to measure temperature. Now let's look at resistance thermometer, RTD. Now resistance thermometer is using metal. Don't forget that the resistance of a melter changes with what? With temperature. Now for melter, as you are increasing temperature, the resistance of that melter, of a melter or a conductor, is increasing. So we are using that to make a thermometer here. So thermometric properties here is what is known as resistance. Then we have thermocouples. Now junction of two dissimilar metals. Now you have, if you join two dissimilar metals together, you get what is known as what? Thermocouple. And the thermometric properties here is known as what? Seebeck effect. Now Seebeck effect is when you generate EMF, you are generating a very small amount of current when you have two junction of melters at different temperature. Now let me quickly explain this. Now if you have two different melters joined together and they are at different temperature, one is at high temperature, the other is at low temperature, automatically electron is going to flow. You know, well, at the one that it is at high temperature, the kinetic energy of those particles that made up of that melters, the kinetic energy will increase. The average kinetic energy will increase, which means that the temperature will increase. And as a result, we have what? The flow of electron from that end to the other end. Electron will migrate, will flow from one end, from the end that is very hot, high temperature, to the end that is very low. So as a result of this, EMF will be generated, and this effect is known as what? Seebeck effect. We also have thermistor. This thermistor is an electronic device. It is very useful in electronics. They are semiconductor, e.g. metal oxide. This metal oxide. Now, it's also using what? Resistance. Don't forget, thermistor can be PTC or NTC. Now PTC means what? Positive temperature gradient. Positive temperature coefficient, and NTC means negative temperature coefficient. Let me explain this. I think I've seen some question on PTC and NTC. I've seen some past question on it. Now, if any material is having PTC, is having positive temperature coefficient, it means that as that material, as the temperature is increasing, the resistance is increasing. That is what we know as what? Positive temperature coefficient, PTC. And if a material, metal, be it metal, semiconductor has NTC. Now, if that material is having NTC, negative temperature coefficient, it means that as you are increasing the temperature, the resistance is reducing, decreases. So that is that about thermistor. Then let's move to pyrometer. Now, pyrometer is used to measure, it's a temperature sensor device, and it's very useful to measure a very high temperature. You don't need to get close to that thing that you're actually measuring. For example, you have what? You have a furnace, and you want to measure the temperature. The temperature is very high, thousands degree. If you get close, you will just kill yourself. So which means any material that you will use, any sensor that you are going to use, must not be in contact with that thing that is actually producing the heat. So now we have the thermometric substance here is object itself, and it uses radiation. It uses radiation to measure temperature, and this one is coming from Stefan Boltzmann law. Now, nobody will ask you any question on this. I'm just explaining this for knowledge sake. Now, we also have pressure thermometer, which is also known as gas thermometer. Now, the thermometric substance here is gas, e.g., we have our helium, hydrogen, and what are we changing here? We are changing pressure or volume. Look at your, what's it called? All this gas law. You discover that as temperature changes, one property is what? Increases or decreases. So general gas law, ideal gas law. So that is what we are actually using to measure temperature. The last thing here is bimetallic thermometer. Now, bimetallic thermometer is different from thermocouples. Now, what are we using here? We have two dissimilar metals again. Metals that is having two different two different capacity. Now, they are bonded together in strip or coil. And what are we using? We are using differential expansion. Which means the difference between their expansion, that is what we are using to measure temperature.